Sorry about that. We had a technical difficulty that I didn't realize had happened. Okay, so as I was saying, 3 can never equal 0. It doesn't matter if it's $3, 3 sandwiches, 3 girlfriends. 3 does not equal 0. No, it doesn't. So that's a moot point. So we would set our two binomials equal to 0 and solve for x, or w as the case would be. Now remembering, this is a length because we're finding we have the volume and we have the height of this tub. We're looking for the width and the length. So this is a distance. Can distance ever be negative? No, it cannot. So this is not a solution. That is not a solution because you cannot have a negative value for a distance. So really, truly, the only value that your W could be for this given situation is a 2. Because length or distance must be positive. We'll write that reminder note. Distance must be positive. You are not Barry Allen. You are not the Flash. You cannot go back in time and create, I don't know, some point. So there you go. I want you to try number 8. So pause the video and see what you can do. Problem 9. So we're going to find the value of x as it relates to the given rectangle. This is more of what we've done. It's just not a word problem. It is a situational setting though. And again, you remember, what's the formula to find the area of a rectangle? Yep, it is what it's been since you were little. Area equals length times width. So we know what the actual length is. That's 15. The length, x plus 2, and the width is x. And yes, you totally could have switched those. That's not a problem. So let's distribute. What's x times x? X squared all day long. Positive times a positive? Positive. 2 times x? 2x. What did we say these have to be equal to in order to solve them? 0. So how do you get rid of the 15? Good, you subtract it. What you do on one side of the river, yep, you do to the other. And we can put this 0 all the way over on the far right. If that makes you feel a little bit more at ease, that's fine. Okay, it's ready to be factored. Let's tear this apart. What's A? Good, it's 1. What's B? 2. Awesome. What is C? Negative 15. You're doing great. So let's build our box with the x in it. What goes in the top triangle? Did you say A times C? I sure hope so. What's that make? Negative 15. Great. What goes in the bottom triangle? B. It's 2. So let's go tear apart this negative 15. And yep, it's negative again. So we're going to have to alternate sides back and forth with a negative in our factors. So 1 times 15, okay. And the other pair is, yeah, 3 and 5. So what are we looking for as the sum? What are we trying to make? Yeah, it's 2. So which pair made the 2 that you wanted? Good, the -3 and the 5. All right, hard work is done. Let's go build our binomials. So we have x minus 3 over our value of a, that's 1, and x plus 5 over our value of a, which is still 1. Let's clean this up. X minus 3, x plus 5. What do we do now? Tell me what to do. That's right, set the binomials equal to 0 because we're going to solve them for x. How do I get rid of the 3? Good, add it across. So x equals 3. Super. How do I get rid of the 5? Good, subtract it across. X equals -5. Which one of those solutions will not work? We talked about this in problem 7. Yeah, it's -5. That will not work. Why will it not work? This is not a solution, not a possible solution. Because distance must be positive. So my only legit possible solution is x equals 3 because distance must be positive. All right, you go do number 10. Remember the formula for the area of a triangle? I'll write that down with you. Area equals 1/2 times the base times the height. There you go. All right, you go do number 10, and if you need any help, let me know. I'll be glad to help you out.